Thank you for joining me, class. Today we are going to move into some properties of logarithms. So now I know the basics of how to calculate them, you know how to graph them. Well, now we're going to talk about their properties. Now, the cool thing, a lot of these properties mirror things that you learned in terms of exponents. What do I mean by that? Well, you know that when you're multiplying things of like bases, you know to add the exponents. Now, what you'll notice is there is a rule that mirrors that idea in terms of logarithms, where if you have a logarithm that is being multiplied, you can actually separate it out by adding it. You know that when you're dividing like bases, you subtract your exponents. And again, there is a law mirroring that in terms of logarithms, where if you are dividing within a logarithm, you can separate it out by subtracting. You know that when you have a power of a power, that turns into multiplication. And again, there's a rule mirroring that in terms of logarithms. If you have an exponent within a logarithm, you can pull it out front as a multiplier. So again, every rule that you learned in terms of exponents actually has a counterpart in the world of logarithms. So let's practice this skill. All right, so there are our rules. So what we want to do, first we're going to learn how to condense logarithms together. Now, to condense logarithms together, that's going to take two steps. First step is whenever I see something out front, I'm going to bring it up as a power. So I'm going to call this log base 2 of x to the 6 plus log base 2 of y to the 5th. So that's using the rule of multiplication and powers being connected. So whenever there's a multiplier in a logarithm, I'm going to take and I'm going to put it out front, or I'm going to put it as a power. Now I see that I'm adding two logarithms together. And again, you should remember from rules of exponents, all the way back in Expo, that adding and multiplying are connected. So when I'm adding those two logarithms together, I can write this as a single logarithm by multiplying those pieces together. And this is going to be the condensed form of it. All right, so again, a little bit new, but again, I don't think it should be that tricky because you know all of these rules already. All right, let's move on to the next one. So here I see subtraction. Well, subtraction is division in the logarithm world. So this is going to become 32 divided by 2. Well, 32 divided by 2 is 16. Now, here's a unique case. Because we're dealing with just numbers, this actually simplifies. Log base 4 of 16. So that's basically saying 4 to what power will give me 16? Well, that actually all boils down to 2. 4 to the second power gives you 16. So there, you can actually write it all the way simplified down to the number 2. All right, looking at our next one. Here I see some addition. So again, what does that mean? Well, it means I can write it as a single logarithm by multiplying those. So I'm going to have 5x times 3x to write that as a single logarithm. Well, 5 times 3 is 15. X times x is x squared. So that's how you'd be able to write that, again, as a single logarithm. All right, so here I see some subtraction, but the first thing I'm noticing is that exponent, or is that multiplier. the multiplier of 2. So first thing I'm going to do is I'm going to turn that into a power. All right. Next thing that I'm going to do, now that subtraction piece right there, that subtraction piece means I can write this as a single logarithm by dividing. Now, 6 squared divided by 9, that's actually just a number, all right? Specifically, that is the number 4. 36 divided by 9 is 4. Now, this is another one of those cases. 4 to what power gives me 4? Well, because I'm dealing with just numbers here, 4 to the first power gives me 4. So I can actually, again, simplify that all the way down to just the number 1. All right. And our last one. So here we have an addition rule. So I'm going to combine those together by multiplying those. Again, when you see two logarithms added, you can write them as a single logarithm by multiplying them. You always want to deal with your parenthesis first when you're doing stuff like this, all right? Remember PEMDAS. Now I can take that 1/2 and I'm going to bring that up as an exponent. So that can either be AB to the 1/2 or remember the 1/2 power is the same thing as a square root. So I really don't have a preference how you write that one. You can write it either way and I will be perfectly content. All that I need though is to make sure that you bring up the 1/2 power, that you indicate it is influencing both the A and the B. So that's how to condense them together. If you have expanded logarithms, that's how you can condense them into one. Now, you can go the other direction as well. You can pull logarithms apart. So, to pull logarithms apart, all you're doing is reversing the things that you saw. So here, log of 4x divided by y. All right, first thing, that 4 times x. The 4 times x means that those were added together. Everything on top means they were being added. Divided by y means you need to subtract off that y. Okay, so when you have multiple things going on, things in the numerator, that means adding. Things at the denominator means you are subtracting them off. All right, that's how you can remember how to expand these out. All right, I need a little bit more space, so I'm going to whip that off my board. All right, log 9. So again, I see division, so that's indicating to me that these are being subtracted, just like that. Now, I see two more things that I can take care of. So here I see an exponent. Now, when you're expanding them, your exponent is going to come out. Oh, not 4. That should be an x. I'm sorry. So when expanding, we're bringing the exponent out. When we're contracting, we put it up. All right, so that little note that I put there was meant to help you remember that. Now, the other thing you should notice, 9, okay? 9 to what power gives you 729? Again, you probably don't know this off the top of your head, but if you look at your powers chart, you can get an idea. 9 to the third power gives you 729. So you can actually simplify that whole thing down to just 3. So always be looking to how you can simplify these, okay? Always look to see if I break these apart, what numbers can I manipulate to make these nicer? And that last one, again, I see multiplying, so the way that I break these apart is by adding them. Two things that I'm noticing. I'm noticing log base 3 of 9. Well, 3 to the second power gives me 9. So I'm going to simplify that down to a 2. Then I also have an exponent that I'm going to bring down. And that is going to be how I can fully simplify my answer. And so again, I don't think this is too difficult. I just think it's a little bit new, so something you're just going to need some practice on in order to get really good at it. There is one last thing that I want to go over. All right, now this is super simple. All you have to remember is the formula. All right, so now the formula actually looks a little bit more complicated than it is because change your base formula. This is how we can use the calculator to calculate any logarithm for us. You've probably been wondering, well, can we even use our calculator for these? Well, yes, you can. And the change your base formula, that is our way of using the calculator because not all of these are going to turn out to be nice numbers. But by using the change of base, this is how we can type it into the calculator in order for us to solve these. And the way you do that is for every one of them, you take log of 27 divided by log of 81. That is all the change of base formula does. Now, why are we calling it the change of base? Well, because our calculators are only programmed to operate in base 10, or later you'll see base E. So what this does is it lets us rewrite it in base 10 in a way that our calculator can calculate. So you take log of the main number divided by the log of the base. So log 27 divided by log 81. And here you get 0.75. That's literally all you have to do for these. That is it. So log of my main number divided by log of the base. So log of 36 divided by log of 5. And that gives me about 2.23. And one last time, log of my big number, my main number, divided by the log of the base, log 18 divided by log of 4, and you should get about 2.08. So again, what does this change of base do? All it's doing is letting us type it into the calculator. It's giving us a way to put these into the calculator so we can get the exact values for them. All right, so thank you for joining me for this. Now, again, hopefully today wasn't too bad, but you do want to make sure you have all of this written down so you can come back tomorrow ready to do your practice work.